very unfavorable term. Therefore, you'll have to catch a loan shark. Okay? So the other thing is how criticality of having cash for any firm, that depends on the probability that I will have a liquidity crunch. Agar if I know well in advance that my cash is going to come and nothing is going to change, then maybe my criticality is a bit lower than when I have got a risky business. Now, generally, the classic book definition of liquidity goes something like this. It's a measure of short-term cash flow, not a long-term, immediate. It's not cash which you have, but the cash flow. Kal parso tak mere paas kya paisa aa jayega. Or the ability, which includes the ability to convert assets to cash. So say my assets are buildings. That's a very difficult thing to convert to cash. But if I have gold, I could sell it immediately and most probably not at a big loss. Right? So that's a more liquid thing than that. On how can I acquire cash? So do I have deposits which I can turant bhaja sake, or I can take quick loan to meet my short-term obligations and liabilities. Again, we're not talking about what I'm going to pay loan tomorrow. In other words, if all I am owed today, if I have to pay today, how much cash would I have after paying everything, and how quickly can I get that cash? Okay? Now, liquidity is studied in many ways. So banks study liquidity because unko cash rakhna bahut zaruri hoga. Central banks study liquidity. How much cash should be there in market? Because if cash is not flowing, things are not happening, economy is not growing. And if you don't have enough cash, then you end up with having a bank run. And we talked about some bank runs yesterday. Right? Because the idea is whatever loans we have given, they will only mature in some time, whereas my depositors can ask for money immediately. A very good example I said we will talk was the Presidency Bank of Bombay. There were 3 presidency banks, Chennai and Calcutta being one of them. So it was established in 1840, and banking was core to the British business. Wherever they went, they established bank because there should be people to take money and give money to you. It was fairly stable till 1860, till the US Civil War started and people started asking cotton from another sources. So India started producing cotton and Maharashtra cotton was important. So that action, that many cotton companies sprung in Bombay. और उसके बाद इस प्रेसिडेंसी बैंक ऑफ बॉम्बे ने लोन देना शुरू किया इन कॉटन कंपनीज को कॉटन पैदा करने के लिए. कई बार लोन्स वेर इशूड अगेंस्ट शेयर्स ऑफ दीज प्राइवेट कंपनीज जो खुद अभी नई बनी है, राइट. बट आप कह रहे हो कि हमारे पास ये कंपनी का शेयर है और वो कंपनी देखो इतना कॉटन प्रोड्यूस करने वाली है, तो आई एम वेल्दी इन शेयर्स. और कई बार जिस पर्सनल सिक्योरिटी पर दे स्टार्टेड गिविंग लोन. व्हेन यूएस सिविल वॉर एंडेड, the cotton supply ended, these people जिन्होंने हमसे लोन लिए थे, they went bankrupt. So they can't give me my loan back. Now I don't have loan either. As a result, I go bankrupt. But very soon, they went bankrupt in 68, 67, and by 68 we had a new Bank of Bombay which was established, which later went on to be part of the Imperial Bank and then State Bank of India. Something similar happened in India जब स्वदेशी मूवमेंट चल रहा था. तो स्वदेशी मूवमेंट में एक फीलिंग थी हमारे हिंदुस्तान में कि हम सब कुछ स्वदेशी करेंगे, कपड़े पहनेंगे, किताब पढ़ेंगे और बैंकिंग भी स्वदेशी करेंगे. We'll not go into a bank run by Europeans. So a lot of banks came up in स्वदेशी movement. Then World War शुरू हो गया. So before these Swadeshi banks got established, or a lot of them were open with Swadeshi flavor, but a number of जो लोग चला रहे थे उनको, they did not have the capability or awareness of how to run a bank. A very good example is the Indian Species Bank. That gave a massive loan to a pearl manufacturer who could not meet the loan. So one big loan ended up taking the bank down with it. So I was yesterday doing a Google search for British Species Bank and I came up with some very interesting court cases. which ran much after the Indian Species Bank had collapsed, because it had given money to people, it was expecting money from people, and that never came back. So many of these Swadeshi banks collapsed. Our bank collapse kept on happening. I mean, we're still having smaller collapses. The smaller banks, when they collapse, you don't hear of them. I mean, there was Sahara's collapse, which happened sometime recently. Right? Till the banks were nationalized, which took the risk of collapse out of them. Now, most other countries do not have a nationalization of the banks, particularly the one in Western world, but the government still insures your capital till a certain sum. So your deposit till a certain sum. So for example, in Europe, your wealth till 100,000 euros in any one bank is insured. So if the bank goes bust, the first 100,000 euro you will get, but anything else is your risk. Okay? And banks can go bust. So this thing also happened in US, and this was only happening 2 years ago. The interesting bank was Silicon Valley Bank, which was a big loaner to startup capital. Things like Airbnb took loan from them to start up. And some of the biggest tech ventures had taken money from Silicon Valley Bank. Now, because Silicon Valley Bank also had deposits of some of the fairly rich people, now if you want to be a stable bank, what do? Where do you invest your money in? You give money to the government, thinking government is going to be a stable source of it. So US government issues these bonds called treasury bonds. Essentially, the US treasury bonds, and they're given at a certain token, so that you will get so much money at every few months while you have given us money. Now, the treasury bonds interest rate is market driven quite often, but also is fixed at a starting. हम आपको इतना interest देंगे. But with time, the average interest rates in the market went up. The Fed increased the interest rate. तो अब जो हम अपना करोड़ों पैसा दबाए हैं, उसमें हमको 2% इंटरेस्ट मिल रहा है, और मार्केट में 5% इंटरेस्ट मिल रहा है. हाइपोथेटिकली लेके चल रहे हैं. तो मेरा 2% वाला इन्वेस्टमेंट तो बहुत बुरा है ना. फिर क्या हुआ कि सिलिकॉन वैली बैंक से कुछ लोग पैसा निकालना शुरू किए. तो अब मुझे पैसे कहां से मिलेंगे? मैं अपना एफडी बेचूंगा. राइट? एफडी मैं इन कैश कर नहीं सकता. आई कांट इन कैश माय एफडी, आई विल जस्ट सेल माय इन. सो nobody would like to buy my FD of 2% right now when they can go and invest in a 5% FD. As a result, I will have to pay it at even lower price. But they started selling their treasury bonds at a much lower price, and in due course of time, it was too difficult for them to sustain there. The cryptocurrency hit led to First Republic Bank and Silvergate Bank. And then many other factors came together for Signature Bank to collapse. And this is when the Fed came in, because if we have one after one other banks collapsing, things may go downhill very soon. Now, so this is a classic forecasting problem. I don't know what I will need tomorrow. We did a bit of classic forecasting problem in the morning, and even that was tricky for an individual. So for large corporations, so till now we talked about banking liquidity. Now firms also need liquidity. If you're a firm operating only in India with only one subsidiary, life is comparatively easy. But if you're a large multinational firm having multiple subsidiaries operating in multiple countries, then knowing how much cash I need to keep at the corporate level, because I don't see day-to-day operation of every small entities, right? And each is operating in a different environment, each is making different product. Okay? So can you think of, say, let's take an example of Tatas for that matter. Who owns Tatas in India? Who? Go on, that's perfectly fine, you can come up with it. So who is the majority shareholder of Tata's? Tata Sons. You know, Tata Sons owns many small companies like Tisco, Telco, and there are others, Tata Consultancy Services for them. Who is the majority shareholder of Tata's? Yeah, so who is their majority shareholder? Sorry? Tata, the individual you're talking about. So this is where Tata is a very interesting company. There are two companies I often talk about, Tata and Bosch. Bosch in Germany and Tata here. So Tata is majority owned by two charitable trusts, which are named after this. Well, actually, there are the groups called Tata Trusts. There are many trusts. They are named after this one, Noshrawanji Trust, Ratan Bhai Trust. This is, I'm talking about the son of Noshrawanji Trust, the first trust, right? These trusts are primarily the owners of Tata Group. And this is why when Ratan Tata was the chairman of the trusts, he was the charitable entity, they had enough power to remove the chairman of the Tata Group. It's Irish mystery because they were the majority owners. Okay? So it's an interesting firm that most of the profit garnered goes towards the charitable purposes. There are few families like the Tata family, they would be owning in single percentage digits of the ownership. Mystery family owns it. So there's all owning 3, 5, 10%, that kind of thing. But the majority shareholder is by the trust. And same with Robert Bosch. Majority trust is owned, I think Bosch family owns 9% kind of thing, and the rest of it, don't quote me because my numbers may not be correct here. The majority is owned by, is a charitable trust. And then, of course, there are cooperatives, where they're large firms, but they're owned by their own employees. So say for people like Tata's, which they are operating a large number of different businesses. So Telco is making locomotives, steel is being made, and then there's a computer science part, then there's a hotel chain, there's an airline now, right, as well. Each is having a different cash flow entity. Now, when I'm sitting at the board level, I don't need to know the entity, but I need to know at the board level when my whole board go bankrupt. So that becomes a fairly challenging, complex task. We're not going to do this exercise because we're still struggling with 14 sets data, so we're not going to deal with that. I will tell you how we ended up doing this thing. Now, many of these firms, the way they do liquidity planning is they have experienced finance advisors who have been sitting in the firm for a long period of time, and just out of their experience, they come up with a number. The number is predominantly a naive forecasting. You basically look at the last month digit and the past of it by a bit of your memory. So overall, हमको इतना पैसा चाहिए. Now, of course, it suffers from limited accuracy and trustworthiness. It works because that's the only model you can do. Otherwise, it becomes a fairly complex model. Now, you could do a time series analysis. You can do an internal data analysis for one or few months in the firm. Like, okay, we have seen data in past. Can I do time series analysis to predict market? Now, unfortunately, large firms do not operate purely on their internal data. So yes, I am going to make so many things. Yes, I know my customers will be. We are also bound by the external data, which is not internal to us. The market conditions. Say TCS employs people or is buying products or is selling products to European customers, right? So European customers are paying them in euros. Tomorrow euros collapse. I'm paying my employees in Indian rupees. If euro goes down, I'm going to suffer a loss of money, right? I still have to pay the same Indian rupees to my employees, but I'm getting less income. Commodities pricing. If I'm a manufacturer, for example, I'm a telco, I'm going to buy, say, paint to paint all my cars or my trucks. The paint cost goes up. It's not in my hand. I didn't plan for it, but market commodities has changed. Weather patterns. Which part of Tata's will suffer from weather? They make salt, don't they? That could affect geopolitical consideration. I mean, we were selling a decent number of product in Russia. The war starts. Americans don't want us to do any business with Russia. And that causes quite a lot of... So these things are going to cause me cash problem as well. They're not my internal data. So purely analyzing my internal data is not going to... I mean, most people will give me an answer, but may not be very decent answer. Now, typical historic research in liquidity has primarily looked at bankruptcy prevention. How much money do I need not to go bankrupt? दिवालिया बचने से बचने के लिए कितना पैसा चाहिए? That's the primary concern here. But the problem these days which is happening, say one sector collapses. We just saw what happened to bank. One bank collapse, it leads to a cascade issue. So financial crisis from one person to another person can also cause concern to me. And this is why purely internal determinant is not the best way, may not be the best to reflect it. Now, so that's why we counted that there are two input parameters. One is output is liquidity. Input is my firm's financial data and the macroeconomic parameters. Now, the relationship between these two is difficult, if not impossible, to derive because it's a very complex interworking of data here. So we're going to assume it is as if it's a black box. This amount of data we have, because we are a large firm, we have got history from there, and just assume it's a black box of something. With some prior intelligence, because make it a complete black box, we'll never know when it will converge and what kind of models to use. So we're going to use some prior intelligence of known situation, how the bank's situation has operated for faster conversions. And this leads to what could be my external variables. I did say, yes, there is external market is going to affect, but what? What number should I change? So we did a bit of literature search. Things like inflation is a good metric. It's a national level metric. Exchange rates, interest rates. So if people can get more interest from bank, they will not buy stuff, they'll just put their money in the bank. GDP growth, that's going to tell me how many people will be tomorrow ready to buy things. So good, so that was our approach. So we looked at the data from the past. And then the expert prediction was a naive based on the last month. We also used standard time series analysis, the autoregressive integrated moving average. So moving average plus some regression based analysis. And then we applied a new learning scheme called Cubist, which is a rule-based regression algorithm. Okay, so we apply rules, and I'll explain to you simply. It combines a part of decision trees, the kind of trees we have seen, and a part of linear regression as well. So both of them, it merges together to do that. So idea this is, so you take a time series data and you split into smaller chunks of time series data and you predict on each one of them. So each branch of this chunk is utilizing a new rule or a different rule with intermediate linear models at each tree step. So each tree is following a linear model, and then the terminal one, you smooth it by some linear predictions from the previous one. So there's two-step process here. One is to divide data into two different subsets, and second is to apply regression models to individual subsets, something like this. So you have a rule which divides the rule into different subsets, and once you have applied, you try to fit a regression model on each one of these data, and then you bring them together. So that's what we are going to do. And now we will talk about things which has troubled us the most this morning. What has troubled us the most? Arranging data. We saw the data yesterday. Data था हमारे पास, हम सोचे कि बस आज तो 2 मिनट में कोडिंग हो जाएगी. और उसके बाद रियलाइज करें एक तो किसी ने कॉमा लगा दिया था, एक empty space था. And that troubled us a lot. Coding was not that tricky. वो तो copy paste कर रहे थे. So this was the same problem which we faced here. So what is the data we need to measure liquidity? One is inflows, क्या पैसा आने वाला है. Another is outflows, क्या पैसा जाने वाला है in immediate future. So inflows are customer payments. Customers will pay me, not orders. Orders जो already हो चुके हैं, जो हमारे पैसे आने वाले हैं. Outflows क्या है? Things which I have to pay to suppliers, my payments to employees, and dividend payments. Okay. And then you need to cluster them because employee payments are also different in different parts of the world. A very good example in Europe, in many countries, you often get a 13th month salary as a Christmas bonus. Okay. So if you're only predicting for 6 months, 6 months around December is going to be a different prediction when it comes to my outflows. I know I have to spend more money during that month. Dividend payment only happens after the shareholders have had a meeting. So if we have a meeting, say in March, in April, my outflows will increase. My inflows haven't changed. Right? So inflows will be following a certain trend, my outflows will there. And then each subsidiary is going to have a different cash flow strategy, cash flow problem, because they're operating in different business areas, have different growth. So we started clustering first. Remember the clustering which we were talking about, to cluster groups in different types of activity. Right? So that's the first thing we did before we did regression. Let's cluster each one of them separately. And then we also removed traditional components like capital investments, because that is not what we think is purely part of liquidity, because these are driven by manual decision. कल को हम एक factory बनाना चाहते हैं, एक और जमीन खरीदना चाहते हैं. They are not time series decisions, they are spot decisions. So you can't really predict for such things like this. So 48 monthly time series data was collected between January 14 and December 18. This was a data we used. And then we had different clusters. We had net cash flow cluster, customer receipt, and payment to suppliers. And generally, most large firms will have an ERP system to give you this data. Okay. Now, you could also cluster your whole thing based on the market or the business area they're working in. So you can say, okay, all of those working in Europe become one cluster, all regions working in US becomes another cluster, Asia becomes another cluster. We did not do that. Because when I'm sitting at the board, I'm not really interested in how much money Europeans are going to make versus how much Indians. Overall, what my board wants to know. That's more important to me. Okay? So we did not cluster based on the separate thing. The other thing is, at corporate level, I have very sparse data. I have one data figure for the entire firm. Right? Itne $1 billion chahiye the hame. That was one figure. I don't have the individual viewpoint. How is it moving? So we had to go down to a subsidiary level and do cash flow analysis at these subsidiaries. And over a period of time, subsidiaries also changed their way of working. So that we had to ignore quite a lot. So we looked some of the cash flow from their balance sheet, and also things like the online transaction process system like ERPs, as well as OLAPs, the online analytical processing, which is there in the firm. Good. Then let's do a quiz question here, and let's do a thought process. I talked about some of the data which might be needed from the external factor. Let's do a discussion between ourselves. If we are designing that system, so internal data is this, we know. Internal data in the sense how much money I expect to see, what I need to pay. What external factor should we consider if we are a large firm? So exchange rate we have already discussed, right? What else? Net worth of whom? Because our data is already there. That's internal. I'm talking about external data. Health insurance, insurance costs. But that I'm already paying to my employees. So the firm is not taking an insurance cost. So data which is not related to my firm. So exchange rate is not related to my firm. It's a rate between two countries. So think about external market factors which could influence our operation. Good. Very good line of thought. So what does the share market is going to do? But we can't look at individual shares. So maybe we can look one of those metrics like Standard and Poor or some industrial Dow Jones industrial average, because that is reflecting the wealth strength of the economy as such. और क्या ले सकते हैं? War based stuff. How do we translate that to numbers? Sorry? Remand? If there's a number, we can get it. What else? How do I translate that to numbers? Natural disasters, yes. Number of times in a year. Past data says some form of weather data. That's what you are looking at, right? That could influence this. What else? Again, the question, how do I translate it to numbers? I agree with you. But remember, we had this problem of translating male and female to numbers this morning. There was 2 points, right? Of course, we can do a natural language processing and extract some stuff out of this, but let's keep a step back. Computation of some sort, yes, very good point. I'm making you think, because often as data analysts or data programmers, we don't think about the data kahan se aa raha hai. And that's critical. A long time will go in data. Coding hum log kar chuke hain. Libraries bani hui hain. Most of them. Of course, there are some people who would go and work on making better models. That's perfectly fine. Anything else? Employment rate. That's a very good measure. Because that tells me how many people are employed and may have cash to buy my stuff. Generally, birth rate is a good number, I come with you, but most of the people who are being born immediately are not going to be my customer. Unless, of course, I'm selling baby milk. Yeah. No. Taxation rate, well done. Now, skill rate, I was going to ask you, so how do we measure? Do we measure based on number of people who appeared for IIT entrance? I'm just arguing on what could be. You might be right. Maybe number of people who are being trained or graduation rate. Remember, right from the beginning, I did not tell you what my company makes. All I said, it's a multinational firm. Yeah, I'm not allowed to tell you. Even in my research papers, you see, we can't name the firm. You can make a guess of the name of the firm based on the affiliation of my co-authors. All I can say, you I'm a multinational firm. So we are doing a black box analysis. I'm too big for customer reviews. If I fall, I take down the whole country. I'm that big. Okay, there are some firms, if Tata collapses tomorrow, there will be a big problem. I'm one of those. Okay, so, so this is what we did. So internal factors, we had these two: turnover, account receivable, account payables, and purchase expenses. We look at the forex rate, for example, USD Euro forex rate. Stock index, we're a German firm. We took the DAX, but we took stock index per country. So DAX there, the Dow Jones. And then we look at the stock index for industry as well. Like there's Tech DAX in Germany, there's Dow Jones Industrial Average in US. We looked at commodity prices. There's something all manufacturing firm needs to use. Oil, gas, naphtha. Okay? Energy prices, they're important for me. So if energy price is going to change, my input will change in due course of time. And not only that, they in turn affect many other things. If energy prices go up, inflation will go up next year. That will lead to increase in my employment costs. We also looked at macroeconomic indices per country. Why is this not working? So this is what happens when you move from one machine to another. So we looked at things like the Consumer Confidence Index. So there is a metric. US Industrial Production Index over. We also looked at things like German Car Manufacturing Index. Because car ownership and car purchasing is going to tell us about the health of German economy. Okay. If you're in India, maybe you can also look at the agricultural indices which are there. Okay. And then, of course, we had to clean data. Data was not nice. I'm going to talk about this. We started with a figure something like this. You have an anomaly that does not look right. So similarly, had we plotted our financial data today, GIAN, one of the person would have got a 0 in 1 month. That was an anomaly. It cannot be right. Right? So it had happened as that data was shifted by there. Now, if I go by the same strategy, if I look at over many years, that's not an anomaly. That's a seasonality. And that's a feature I need to know. I know my supplier payments are going to be seasonal, right? So my suppliers make a much larger payment in the month of May for some reason, May and November, right? So that's a feature I need to know. So I should not be removing this data. So sometimes a data may look anomaly in short distance, but had that same person given us data for multiple years, in every June the expenditure is zero, which is possible. The student has gone from his home to his family's home. और फिर माँ बाप खर्चा कर रहे हैं पूरा. That's a possibility. We know that was not a possibility in our data case, but that is a possibility. Then the question is ये कि हमने predict किया, अब हमको compare करना है कि हमारा prediction कितना अच्छा है. How good is my prediction compared to an actual value? So did we look at any metric last few days or have we not? So we used the direct performance metrics as provided by the metric library. Now a good number which many people use is root mean square error. Right? So you take the difference of the error, square it, add all of the errors, divide it by the number of particles and take a square root of that, because it's considered a fairly neutral error to positive and negative ones. We decided against that because we wanted something which treats positive and negative errors symmetrically. So we went for a mean absolute error. Okay. Now, there's an interesting case for liquidity. If my liquidity is going to be high, if I have a positive error in prediction, that's generally okay, which means I will have more cash. Okay. If I overestimate my net cash flow and I don't get that much money, my actual liquidity goes low. So negative error in prediction is actually worse than positive error in prediction. So these are not symmetric per se. So the classic simple matrix which deal at any error symmetrically are not necessarily the nicest error when you're looking at cash flow. Look at this your own way. Cash flow jab prediction karenge, whichever model you are using is using a root mean square error. But you like to be positive rather than negative. But in all of these, positive and negative are equal. Unfortunately for us, our firm didn't care about positive or negative error. They're too large for this thing. So we went for a mean average error, which is this. You basically take the average value and divide it by n. In our case, we also took a relative mean average error because there were some points where the data was becoming too curved. So we divided it by the average. So whatever is a mean average error, you divide it by the average of the values, and that's what we used as our performance metric. Good. Remember, we wanted to say how good are we compared to an individual or compared to time series analysis. This I have already talked about. The way we predict it is we're looking in this 6-month slot, and the 6-month slot we're moving. And in real life, also this is not just prediction is not the sole goal, it's to prepare the board. So in every month, you predict something, the data takes up, every new month data, it puts it back into the system, retrains, and then repredicts for next 6 months. Now, as you can see, some of the errors I would not be able to tell you the exact value because I'm restricted by my corporate partners. But this is what reflects how good or bad it was. We're reflecting in 6 forecast steps. 1 month from now, 2 months from now, 3 months from now, 4 months, 5 months, 6 months. So if the error is highest, the darker the color is, you can see the naive error was fairly high over the years. But later down, the naive starts working fairly okayish. So people with experience can tell you in a year's time that will be needed, but immediately next month we'll have high error. Because with experience, it averages out all the bumpiness in your data. Okay. Cubist, the learning always performed better than Ariba because Ariba was only looking at my data series, my time series. Now we're looking at my series plus everything in the market. So rather than boring you more with this, I'll just tell you some of the results. So here is a result comparison of our analysis versus what was being used in the firm automatically, how accurate were. So if you look at the aggregate, So over aggregate, we performed fairly better. So blue is the machine and the orange is the individual. We performed about 10% or 9% better in net cash flow. So we could predict net cash flow right now for a multi-billion-dollar company. 9% better prediction translates into a very large sum of figure. Okay. So they were, earlier also they were accurate to within 82%, and now we could do this better. If you boil down to subsidiary levels, and if you look at the customer receipt forecast, actually the difference is not that terribly high. It's possible because each subsidiary operates differently and we are trying to apply one model to everyone. So one model fits all is not necessarily the best solution. But if you look at individual month predictions, we are doing better than many of these things. When it comes to supplier payment forecast, so customer receipt forecast, we believe supplier payment, what we need to pay to our suppliers, that we did significantly better, okay, at least 1% better than, and even at subsidiary level. So we're doing better at that job. So it's a fairly complex system which was designed. It is now used in the firm. So they are using this to make their predictions. But at the board level, it saved quite a lot of money. Maybe at the subsidiary level, we should have used a different model than the single model which we go for. Okay. So I'm purposefully keeping away from maths because this is kind of our last session and I would like it to be pleasant rather than boring you with loads of equations or coding. Let's do a bit of discussions as to how to and when to forecast. We should not be using a neural network every now and then. Okay. So if you make a prediction, it should be something which should be visualizable and interpretable. My business colleagues will not be looking at this 1% or 2% data accuracy. So any prediction should be tied into the ERP system of the firm itself. The other thing is it does not always hit at the first time. There's a cost-benefit analysis. You need a computing power, you need to pay a computer scientist. So it may not be best for every firm, but it always works in the long run. The initial investment helps you in the longer run. The similar questions were being asked about use of computers in Indian Railways. Early in the beginning when computerized ticketing came in, people said, why do we need this? We still have loads of ticket issuers and computers are costly. A computer costed more than an annual salary of that person. Now we don't, are there ticketing machines still left? Ticket boxes? Do people still go and buy their tickets or they're all gone now? But the number would have reduced significantly. Right? The question to ask is, can data from one firm or can analysis of one firm be applied in another firm? We don't know that because we have not tried this, but there should be, there are different seasonal patterns for each firm. There's a different volatility. There's a different type of data availability. So bottom line is we are saying कि हमारी नौकरी और है. एक data is not going to be, or एक analysis is not going to be applicable in every firm. Last but least, should every firm go to a computerized or to an AI-based liquidity predictor? Most probably not. If you have low liquidity numbers, if you know your input-output is kind of fixed, there's no use going to do this complex system. If you're a small firm, right, and if after doing this thing, you're only going to make a saving of €1 million or so, maybe it's not, well, maybe in the Indian landscape it is good, but in the landscape, it's not the best. So in the summary, I told you about one of the papers which we worked on, how we use data analysis in a business environment to help the board level without knowing exactly what's happening at individual shops downstairs. How different skills of different type of data was used, how it was cleaned, how it was programmed for. Okay. So hopefully the 3 case studies which we have looked at from the last 3 days, one was looking at filling the matrix of missing user interface. Other was looking at classifying my data. And this one looked at actually predicting absolute values. It was a regression-based analysis, it was predicting a number. This looked at 3 different aspects of machine learning. I purposefully kept it broad for you to appreciate where different domains where it has been applied. Give you a feel of things beyond our typical computer science landscape. Okay. With that, I will bring it to an end for our teaching part, and we'll go back and try to finish our morning exercise to see online. Okay. So let me see if I can somehow find, or should I come and fix this? So how should I do it? Should I do it on the machine and you all can see, or should I come and help make you do it? Make you guys do it. That's nicer. Okay. So we will do this. The other way to check the data analysis could have been to look at the time series of girls and boys. So you have 12 data points or 16 data points. Just plot them against time. Right? Give them different color and just plot them. The visualization will already tell you if boys are above girls or they're just randomly distributed between one another. That would have given the answer to that question as well. Also see if the average of boys and girls makes sense. And there lies the question, how do we do average? There are 3 ways of doing average, at least here. You can average each person's annual expenditure and then average it and compare just the annual expenditure, or you can compare the monthly average of all the people. Does it make sense? So annual average of everyone or monthly average of boys versus girls, we can compare that. Okay. I had also given a backup database of India.csv on the same thing. My idea was, if this did not work, I know that the backup database has got a much larger, I think it's about 20,000 people with both men and women and their financial experience. That would have given us the answer to that question. So as far as these 16 people are concerned, I think none of the random forest predictor are telling us girls spend more than boys, at least till now. Right? So, sorry, your hypothesis doesn't seem to be right. It just seems to be the grass is greener on the other side kind of hypothesis. So, how many of you did not give your actual amount of expenditure? हाथ उठाओ. तो आप ही ने चोरी शुरू की. Really? So, कहा जाता है ना कि एक चोर सबको समझता है कि सबके सब चोर हैं. राइट? हम तो चोर हुए ही, सब थोड़ी बहुत डिसऑनेस्टी करते ही होंगे. But there are actual data predictions. People have studied this thing. And yes, you are right to some extent, but the expenditures are different between boys and girls. So we looked at the Irish data yesterday, when the alcohol expenditure of boys was more than the girls, but housing accommodation for girls was higher than the boys. Right? So if you look at the overall expenditure, the toiletries was higher for girls, but shoes was higher for boys. So overall expenditure is not terribly different between these two. या आपको भले लगता होगा कि आपको अपनी बेटर हाफ को पेमेंट करना पड़ता होगा खिलाने के लिए, या फिर आपसे लोग निकाल लेते हैं लड़कियां ज्यादा, which is your stupidity. That has got nothing to do with gender biases. Good. I will come back to your chairs and then we will see how it goes from here. Works online, and I don't think you have energy to listen another lecture of mine now. So if you are interested, go back and read on it. We can, if anybody is interested further in discussing this, you can always write an email to me and my secretary, and we can set up an online meeting. Okay, but nothing will happen till March, because till March I want to see India. Okay, good. I will now come to your systems. क्या हो रहा है आप लोग का? अब घर जाना चाहते हैं सर, रांची वाले बोर हो गए सारे. घंटे बाद बाद फ्रीडम मिल जाएगी तुम्हें। क्या हो रहा है बाबू? You want a medicine? You want it? कहा उनको करने को। देना बाबू, इसको हटा दोगे जरा। So I didn't do this analysis. This is analysis done by our stellar colleague here. And you guys can see this data, right? He just puts the average cost in 2023 and 2024 per month. Blue are the girls. There was a shock. ये तो नहीं हो सकता. Huh? मैंने नहीं किया है, किसी लड़की ने भी नहीं पैदा किया. So you can go and check the data. और या फिर why don't we do this thing? You have got the whole data, right? You do the same thing. Just plot the average of these two and let's see what happens. बाहर खाना कम करो, लड़कियों को ब्लेम करते हो. अच्छा, लड़कियां आपसे खर्चा करवा रही है, हमारे तो जा रहे हो, ब्लेम उन बेचारी को कर रहे हैं आप लोग. हाँ, see, I have got both a son and a daughter, so I can't be biased towards any. Though my daughter is only 3-year-old and my son is 10, my daughter has learned कि भैया मुझे हिस्सा लेना है सब चीज में, बराबरी का. राइट? तो अगर भैया को टैबलेट चाहिए तो हमें भी चाहिए. Your identifier is not found in Access. कॉल इसमें एक ही स्पेस है क्या? Let's look at this data.
I don't think it's not identified. It's this line, no?
Key error. So let's do this thing. Let's remove just your identifier. Sorry, क्या हो रहा है? Let's remove your identifier. I know हम थोड़ा चला रहे हैं इस पर अभी. Let's see if everything else works. So the only thing which is working, not working is ठीक है. देखते हैं क्या है. So can we look at this code? There is a semicolon after that. No. If I can. Excuse me. What does it say? कहाँ एक्सेल में खुला है कहीं? तो let's look at क्या है इसके. उसके बाद में स्पेस है. Bravo. Now all I have left is timestamp and these figures. Some of them are not available, but they are there. अब compile किया जाए. Okay. इसके रन से split किया जाए. And learner predict किया जाए. Y predicted plot कर रहा है. Let's also print Y test. Okay, तभी न जानेंगे हम कि कितना अच्छा था. So 1 is boy or 0 is boy for you?
0 is boy,
1 is girl. So somehow it has taken all the. So it thinks everyone is a girl here.
So is boy.
So let's make 0.5. Let's take थोड़ा ये बदला जाए. Let's change the parameters. Number of estimators 100 नहीं हो सकते यार, क्योंकि 16 ही data samples है ना. And now it's not that bad. It may got few wrong, well, got many wrong. Plot तो नहीं करेंगे हम लोग, accuracy calculate करेंगे. There was an accuracy calculation part last time, right? But till now it's working. Now you can start playing. सभी मैंने data set बहुत बढ़ा दिया है इसको, तो 0.1 करते हैं और 0.2 करते हैं, 1 ही रखते हैं. Let's see. Okay, so 1-0 guess करना था, it guessed 1-1. That's 50% accuracy. We know. Why is that is 67% accuracy. That's not bad for a small, जितना छोटा data set रखे हैं हम लोग, right? And now you can do, जब division कर रहे हो, you can change the state so that it divides it differently. Now it has divided and still it has got 62. 3/4 is 75% accurate. इतना बुरा भी नहीं है. Okay. So bottom line है, code को simple रखिए. Good. आप लोग का क्या हो रहा है? Luck? No luck. कोड तो काम करवा के ही रखूंगा मैं. Let's see क्या प्रॉब्लम हो रही है. So you have got it working, is it?
Yes, sir.
And your accuracy is 71%. Why don't you list? I mean, how do we know कि किसको गलत estimate कर रहा है? Boys को girls estimate कर रहा है कि girls को गलत estimate कर रहा है? So what you could do here is you can just print them. Print y test, print y predicted. And we can see it here.
And sir, after the graph change,
So what do we want to see?
boys versus girls for graph expenditure income.
तो पहले या तो एवरेज निकाल दो, एवरेज का एक्सपेंडिचर करो, राइट? और we can do mean per row और mean per column and then करके देखो. What's happening, guys?
Sir, about 50%.
50% accuracy. Now, this is where things are a bit tricky here. So the number of estimators which you have used is a bit large. There's only 16 samples we have.
So I use 220.
No, we can only use 2 or 3 now. Cannot form 200 trees from 16 samples,
Okay.
right?